Okay, we will discuss about the geometric sequences. Okay, that is, just we have seen sequence is the function whose domain is the set of natural number or positive integer. And when it's a geometric sequence, it's the type of sequence in which the ratio between each consecutive terms of the sequence are non-zero constants. That is, let G1, G2, G3, G4, like this one, of Gn are terms of the sequence. Okay, these are the terms of the sequence. So these terms of the sequence are geometric sequence if the ratios, okay, that is G2 over G1 is equal to R, G3 over G4, G3 over G2 is equal to R, G4 over G3 is equal to R, and like this one, okay, of Gn over Gn minus 1 is equal to R. There's a common ratio to constant kohone, okay, the ratio between each consecutive term non-zero constant kohone, so the given sequence is called geometric sequence. In this case, how can we find the nth terms of geometric sequences? Nth terms of geometric sequences እንዴት ነው የምንፈልገው? ይሄ ጂኦሜትሪክ ሲኩዌንስ መሆኑን ካወቅ ዛት ኢዝ ሬሾቸውን ወስደን ኮንሲኩዌንቲቭ ተርሙ ሬሾ እኩል ከሆነ ጂኦሜትሪክ ሲኩዌንስ ነው ብለናል። ሶ ሃው ካን ዊ ፋይንድ ዘ nth terms of this geometric sequence? ኦኬ ሶ ፍሮም ዲስ ዋን ኦኬ ከዚህ ላይ ምንድን ነው የምናገኘው? G2 the second term ማለት ነው is equal to R times G1. From this one, G2 is equal to R times G1. Again, from this one, G3 is equal to R times G2. G3 is equal to R times G2. That is R times G2. And we have G2 ማለት ደግሞ R times G1. R times G2 ማለት R times G1. That's R times G1. This is equal to R square G1 ይሆናል። G2 ማለት R times G1 ነው። The second term ማለት R times the ratios times the first term. G3 ማለት ደግሞ R square times G1. And the next one is okay, G4 is equal to G3 times R. And from this one, G3 is R square times G1. That is R square times G1, R square times G1 times R. R square times R is R to the power of 3 times G1. And what about if it is G5? Okay, that is G5 over G4 is equal to R. Common ratio to constant መሆን አለበት. This implies G5 is equal to R times G4. This is the same with R times G4 means R cubed times G1. This is the same with R cubed times R is R is the power of 4. That is R is the power of 4 times G1. So from this one, G2 is equal to R times G1. G3 is equal to R square times G1. G4 means R cubed times G1. G5 means R is the power of 4 times G1. Look, G4 R is the power of 3. G5 R is the power of 4. And ይቀጥልና Gn, the nth terms of geometric sequence is equal to R is the power of, that is, if it's 5, it's 4, it's minus 1 እያለ ይሄዳል። R is the power of n minus 1 times G1. So, if the given sequence is geometric sequence, that is, if it do have the non-zero constant, ratio non-zero constant ከሆነ the nth terms of the given geometric sequence is R is the power of n minus 1 times G1. The first term times the common ratio R is the power of n minus 1 ይሆናል ማለት ነው። So based on this one, let's create an example, okay? For example, okay, let's the sequence is this one. The sequence is 1, 3, 9, 27, 81, like this one. Find the nth terms of this sequence. So the first step is we have to identify what kind of sequence is it. So let's find the common ratios, okay? R is equal to second term over the first term is equal to 9 over 3 is equal to 27 over 9, which is equal to 81 over 27, which is 3. That means the sequence is geometric sequence. So the nth terms of this sequence is, by using the formulas, Gn is equal to G1 times r to the power of n minus 1. That is, the first term is 1 times r is 3 to the power of n minus 1. That is, the nth terms of any geometric sequence is, so that is G1 times r to the power of n minus 1. In this case, the first term is 1, that is 1 times 3 to the power of n minus 1 is 3 to the power of n minus 1. So the nth terms of this geometric sequence is 3 to the power of n minus 1. G1 ብንባል 3 to the power of 1 minus 1. That 3 to the power of 0 is 1. G2 ብንባል 3 to the power of 2 minus 1 is 1. 3 to the power of 1 is 3. G3 ብንባል 3 to the power of 3 minus 2 is 2. 3 square is 9 ይሆናል። We might be asked like G5 ወይም ደግሞ G10 ብንባል G10 ብንባል that is 3 to the power of 10 minus 1 which is equal to 3 to the power of 9 ይሆናል ማለት ነው።